Hello and welcome to our latest video. This time we're going to be looking at how to use DNSA reagent to quantitatively test an enzyme's rate of reaction. So when you receive your DNSA reagent, it will look like this. It will be a cloudy yellow colour. You want to add 20 ml of 2 molar sodium hydroxide to this, and as you'll see, it will then change colour to orange. You then want to add in 13 ml of deionized water or distilled water to get it to be the correct concentration. Mix that, and then that is now ready to be used. So for this experiment, we are going to be using Invertase. So if you buy your Invertase from us, it comes as a concentrated solution, which you can then just dilute. So for this experiment, we're using 0.01%. So to make this up, you would take 10 microliters of the concentrated solution and dilute into 100 ml of distilled water. Now we are then going to be using 0.4 molar sucrose solution, and to make that up you want 13.69 grams of sucrose in 100 ml of distilled water to give you a 0.4 molar solution. So if we then have a look at the temperature profile for Invertase, you can see that the temperature rises quite rapidly from about 30 degrees up to 50 degrees. It then plateaus and then comes down quite rapidly over 60 degrees, and the enzyme is denatured by 70 degrees and there's almost no activity. So this will be useful to bear in mind when selecting the temperatures for the rate of reaction experiment. So we're now going to have a look at using DNSA reagent to quantitatively monitor the rate of reaction using temperature as a variable. So we're going to start by using 35 degrees and our ready to go DNSA reagent that we've already added our sodium hydroxide to. So what we need to do is we need to have 11 test tubes labelled from 0 up to 10, and then add first of all 0.3 millilitres of DNSA to each of the test tubes. So once you've done that for all of the test tubes, then you're ready to move on to the next bit. So the next bit is to then add 0.3 millilitres of sucrose to the tube that you've marked with the number 0 on, and that's going to be your blank. So you're not going to add any Invertase to that one. That is going to be the one that you're going to use as the blank on the colorimeter. So give that a mix, and then you're ready to move on to the next step. So obviously double check that your water bath is at the right temperature. You want to put your sucrose in and your Invertase to acclimatise to the correct temperature. So here I've taken 10 millilitres of the sucrose solution that we made up earlier, so the 0.4 molar sucrose solution. After both the Invertase and the sucrose have acclimatised to the correct temperature, so in this case 35 degrees, you then want to take 1 millilitre of the 0.01% Invertase and add that to the sucrose solution in the water bath. I'm going to give that a good mix and then set a timer for a minute. After a minute, take 0.3 millilitres and mix it with your number 1 time point test tube. So the test tube that you've written 1 on. That already has your DNSA reagent in it. So get that in there, give it a bit of a mix. So set your timer again and repeat. Every minute, give your solution a mix first and then take 0.3 millilitres of the sucrose that's being broken down by the Invertase. In this case at 35 degrees, take 0.3 mils and then mix it with your next one. So this is the 2-minute time point. So as I say, repeat this for all of them, right up to then the 10-minute mark. So once you have done all of these, so this is now 10 minutes later and we're on our final time point here. So mix, take your 0.3 ml sample, and then that one's going into the 10-minute mark one. Right, so once you've done that, you now need to put them all in a big beaker like this and then boil a kettle with water and then add boiling water to them, because you need to heat them for the reaction to happen. Then put a timer on. So we say 5 to 10 minutes. I usually just do 10 minutes just to be on the safe side, the reaction's been complete. So what's happening now is the DNSA reagent, which is yellow, is being reduced by any reducing sugars that are present to ANSA, which is an red colour. So you get this nice colour change from yellow to red in the presence of reducing sugars, and it will go progressively more red, more of it will be converted to the ANSA, the more reducing sugars that are present. So for samples that have obviously been in there longer, more of the sucrose will have been broken down into glucose and fructose, which are both reducing sugars. So I'm just putting them all in order now so that I'm ready to test them all on the colorimeter. So from 0 right up to 10. Right, once you've done that, then you need to add 3 millilitres of distilled water to each tube, and this is just to dilute the samples before they go into the colorimeter. So once you've diluted all of your samples, you are then ready to set up your colorimeter. So the ideal wavelength is 540 nanometers. So you take your test tube marked 0 and use that as your reference sample. So you 0 your colorimeter using that. And that's the one that didn't have any Invertase added to it. And then you're ready to just start testing each of your time point solutions, and obviously writing down the readings each time. So once you've done this, you can obviously compile the results and then plot the rate of reaction. Now I then repeated the experiment exactly the same, but incubating the sucrose and the Invertase at 2 other temperatures. Obviously, if you've got a class you can do this with, then you can give different groups different temperatures to work on. Now, if we go back to our temperature profile, then we can choose 2 suitable temperatures. So I chose to do 50 degrees, which should give me a really fast reaction rate, and 70 degrees, which should show no or very little reaction because the enzyme should have denatured by then. So you can see here, this is at 50 degrees, and you can see the very dramatic colour change, and then 70 degrees, and you can see there's very little colour change. So I obviously took the regions on a colorimeter for both of these, and these were the results when I've just plotted these on a graph in Excel. So you can see when you compare the different temperatures how the reaction rate increases with temperature right up to about 50, and then you can see how the reaction rate then drops to almost nothing at 70 degrees, showing that the enzyme was denatured at this point. So this is a brilliant way of quantitatively looking at enzyme reaction rates, and the sucrose and Invertase works really well and really reliably. If you do have any further questions, or you would like to place an order for DNSA reagent or any of our enzymes including Invertase, then please do email us at ncbe@reading.ac.uk. Thanks for watching.